For the past several weeks, I've been documenting my preparation for Lyfgenia gene therapy at City of Hope, the first approved treatment that directly addresses the underlying genetic cause of sickle cell disease. Much of the public conversation around this process focuses on the administrative burden surrounding access to treatment. The prior authorizations, the insurance reviews, the coordination across fragmented healthcare systems, and the dozens of hours spent navigating infrastructure that often feels intentionally difficult to move through. But all of that exists downstream of the disease itself. Vaso-occlusive crisis is the most common acute complication associated with sickle cell disease. Sickle-shaped red blood cells are rigid rather than flexible, which means they cannot move efficiently through the body's smallest blood vessels. Instead of flowing normally, the cells begin to cluster together and obstruct circulation. Blood flow slows. In some areas, it stops entirely. The tissues beyond those blockages are deprived of oxygen. What follows is ischemia, tissue injury caused by inadequate oxygen supply. Body responds to oxygen deprivation the way it is biologically designed to respond, with pain signals intense enough to demand immediate attention. This is not generalized discomfort or temporary soreness. It is tissue damage occurring in real time inside the body. Most hospitals use a pain scale ranging from 1 to 10. During vaso-occlusive crisis, pain frequently registers at the highest end of that scale: 8s, 9s, and 10s. I have experienced this since childhood. On average, at least twice a month for 43 years. The research surrounding sickle cell disease and pain management tells a very consistent story about how that pain is treated inside the healthcare system. A 2016 study published in JAMA Internal Medicine found that Black patients presenting to emergency departments were significantly less likely to receive opioid pain medication than white patients reporting equivalent pain levels. The disparity persisted across diagnostic categories and was not explained by clinical difference. A 2020 systematic review examining racial disparities in pain assessment found that healthcare providers were also less likely to believe Black patients' self-reported pain experiences. Sickle cell disease affects approximately 100,000 people in the United States, and more than 90% of those patients are Black. The disease has been documented in medical literature for more than a century, yet, for most of that history, treatment focused primarily on management rather than resolution. Pain medication, blood transfusions, hydroxyurea, and crisis stabilization. I spent decades becoming fluent in clinical language because fluency increased the likelihood of being taken seriously. I learned how to describe symptoms in ways institutions recognized as legitimate and how to advocate within systems already conditioned to doubt certain patients more than others. That fluency is often framed as resilience. More accurately, it reflects adaptation to a design failure. Today, I work as an AI governance consultant with organizations building AI systems for healthcare, insurance, and financial services. One of the most important things organizations need to understand is that AI systems trained on historical healthcare data are also inheriting historical inequities. Clinical decision support systems are trained on treatment histories, outcomes, physician notes, prescribing patterns, and utilization data. In emergency medicine, that data set includes decades of undertreated Black sickle cell patients and the outcomes produced by inadequate pain intervention. The system learns correlations between race, diagnosis, treatment patterns, and outcomes. But it does not inherently understand why those patterns exist. It does not recognize that many of those patients were systematically undertreated. Without intentional intervention, the model absorbs undertreatment as historical norm and reproduces it accordingly. The inequity becomes embedded inside automated recommendations, triage systems, risk calculations, and coverage determinations. The result is not neutral technology. It is historical bias operating at computational scale. Lyfgenia is extraordinary medicine because it directly addresses the underlying genetic mutation responsible for sickle cell disease, rather than focusing solely on symptom management. The genetic basis of sickle cell disease was identified in 1956, making it the first disease understood at the molecular level. The FDA approved Lyfgenia in December 2023, nearly 70 years later. That timeline matters. Sickle cell disease disproportionately affects Black Americans, and the disparities in research funding compared to diseases affecting similarly sized majority white patient populations are extensively documented. The delay was not simply scientific. It reflected institutional priorities about which conditions received urgency, investment, and sustained attention. Many of the patients who needed this treatment most lived and died within that gap. I am currently in the preparation phase for stem cell collection at City of Hope. 3 double red blood cell exchanges. April 3rd completed, May 5th completed, May 29 upcoming. Stem cell collection is scheduled for June 2nd through 5th. After collection, my cells will be sent to Bluebird Bio for genetic modification. Then comes the waiting period while the edited cells are prepared for reinfusion, a process measured in months and largely outside of my control. This is genuinely extraordinary medicine, but it is also arriving 43 years after I first needed something beyond pain management and hydroxyurea, and that history matters because the same institutional patterns that delayed treatment, minimized pain, and underfunded research are increasingly being embedded into the AI systems now helping manage healthcare access for the next generation of patients. When organizations evaluate clinical AI systems, demographic representation in training data is only part of the question. The more important question is whether the outcomes reflected in that data are equitable. If historical data reflects undertreated pain, delayed intervention, or unequal care, the model may learn those patterns as operational norm rather than institutional failure. Bias exists not only in who is represented in the data set, but also in what happened to them and whether those outcomes are being treated as acceptable. The full written version is available on Substack. Next week, I'll be talking about what 15 years in Japan taught me about navigating systems not designed for my presence, and what that experience reveals about AI governance and inclusive design. And lastly, Lyfgenia. A public record continues. I'll keep documenting this process as I move through it. I am still here. I am still counting.